Welcome you all to this talk about permissionless DEXs. So we from Gnosis, we are also planning to build permissionless DEXs. And so for us, it's very important that we are aware of what kind of technologies are actually used in the space, how do they all work, and what are exactly their advantages, because only if we know that, then for sure we can also build a very successful product. And so we did internally quite a lot of research, and this talk kind of summarizes this. I hope that's helpful for you guys just to get a rough overview about what kind of techniques are out there and what are their advantages. Right, so the talk has the following structure. That first we will look a little bit over at decentralized exchanges in general, then we will look into the different market mechanisms of these permissionless exchanges, and then also have a small future outlook of what Gnosis is actually planning to do. So let's first look a little bit at the definition. So in this talk we make the distinguishing between permissioned exchanges and permissionless exchanges. So permissioned exchanges are exchanges where some part of the trade flow is actually permissioned, and usually this is the part where orders are matched over here with the operator. So usually you have the following trade flow, that you have some traders and then they're sending their signed orders to the operator is doing the actual matching, and then the orders are sent matched to the blockchain where they are then settled in a non-custodial way. And this is a very successful market mechanism, like IDEX, the market leader, is implementing it, looping several relayers on 0x, and so on. But in contrast to that, there are other exchanges which we would like to call the permissionless DEXs. And over here, the orders are matched on-chain via some kind of decentralized algorithm. So you have kind of the following pattern, that again, you have some traders over here, they send the orders directly to the Ethereum chain, and then on the Ethereum chain, they are matched with some kind of matching algorithm. And there are also very cool projects out there, Kyber, East2DAI, Uniswap, and DutchX, and they are all exchanges currently existing. And I want to highlight over here that this is kind of these are definitions that are being formed over time. So some of the people actually call permission DEXs operator-driven exchanges, just because the operator is so central. And then for permissionless DEXs, also some people claim that not all of these exchanges down here are actually permissionless, just because some part is restricted. For example, adding tokens. Right. So what are the tentative features? I really want to emphasize that these are tentative features and not that every permission exchange has the following ones. So usually what you associate with permission exchanges is instant finality and off-chain order placement. Instant finality, if you send your order to an exchange operator and if you trust them, then you can get immediately feedback at which price the order is getting matched. And also order placement is usually just sending around signed offers. And this is very powerful because it's very cheap then to adjust the actual orders. And I think these two characteristics, they are very powerful to copy liquidity from one exchange to the other exchange, and with that bootstrapping exchanges very quickly. So that's very powerful. But the permission exchanges, there is always the possibility that the operator could front run. And also, as we are now seeing with IDEX being regulated and introducing KYC, actually also, of course, they are more likely to be more strictly regulated. On the other hand, for permissionless exchanges, cool features are definitely the atomic trades. That means a transaction either goes through completely or not at all. That means if you have in one transaction two orders that are operating on two different exchanges, then you can make sure that either the whole trade goes through first through the first exchange and to the other exchange, or that none of it goes through. And that's also very powerful for actually using it as a way to do arbitrage. And the thing why I'm really excited about these permissionless exchanges is that they actually provide some liveness guarantees, because there is not some central person that actually could permission you at any time. You can easily use it for building protocols that are basically then the breaking stones for DeFi. So that's what I'm very excited about. That's how we are looking at permissionless exchanges from Gnosis. So let's look very roughly over here at the market shares. I think you all know IDEX is currently the market leader. Over here, the market share is represented by the count of transactions. Like these volumes calculations, they are sometimes a little bit messed up. But here I'm only counting the transaction count. And over here we see that averaged over 30 days, IDEX definitely got most of the transactions that initiated some trade event. Then 0x, like usually you don't see it on these charts, that 0x has this big portion because it's kind of split it into the different relayers. But here I summed them all up, has also a big part. And then we have Kyber, ETHDAI, Bancor, EtherDelta, and Uniswap. And what do all of them have in common? Well, these are exactly the permissionless exchanges. And so we can roughly say that 1/3 of the activity is these days definitely on permissionless exchanges or not on operator-driven ones. So that's very exciting for us. And then we also were looking into how do these numbers basically evolve over time. So we have here kind of the same pie chart, but basically each column over here is one part of the pie chart over the last half a year. And down there you see in pink, orange, and yellow kind of the permissionless ones as ETHDAI, Kyber, and Uniswap. And now if you look at the tendencies, I think there's not really a strong tendency these days, but definitely the market share of the permissionless exchanges were slightly growing.
Can I just ask, interrupt, why do you think that transaction counts matter at all and not the volume? I'm just curious. Why do you think it's an interesting metric at all?
So these volumes are basically also then usually measured in USD, and like the prices of the tokens, they can be fairly often if you don't have a very reliable price feed for basically creating these tokens. Like for example on IDEX there is like many tokens are traded that don't have a very stable value, that don't have that they are not very popular, so with that, like the price could be fairly off, I don't know. And definitely with that, you have some kind of twist. But I'm not saying in general that the look at the transaction count is much better than the look at the USD volume. Part of it is definitely also that these transactions count, they're much easier to extract than the actual volume, because you always need to have these good price feeds. And yeah, if you guys are interested, like these data, they are created with Dune Analytics. I really like the tool. If you're clicking the same link, then you can see exactly how I generated these data and what kind of errors could be in there potentially. So it's very easy to compare. I really like the tool. I just want to mention it quickly. But now let's take a look into the different market mechanism, what we're all here for. So the first one is basically the on-chain order books. Over there, it's very similar to traditional exchanges. So basically, people are posting these limits orders, and then these limits orders are forming these order books, and then market orders are matched with these previously posted limit orders on chain. Like EtherDelta and other stacks, they were both introducing these very early, and I think then EtherDelta also introduced basically that these orders are, ETHDAI is now also enforcing that these orders are sorted in orders so that we can easily on-chain match the market order with the highest limit prices. So the advantage is definitely that this is the continuous double auction, so it's a very well-known protocol which established itself already in all the other financial markets, and it also enables us to have these atomic trades with other DEXs. But of course there's always some disadvantage, and over here we have racing conditions between market orders or taking orders. So imagine there's a very profitable limit order out there, then I would like maybe to take this one, and so I post my order that actually wants to take this limit order with, let's say, a specific gas price, for example, 20 GY, and then anybody else can actually also come in and post the same order with a higher gas price and then actually gets it. But of course, then I want to prevent it, and then I'm also posting a higher gas price and so on. Then the name for this is actually priority gas auctions, because in the end, it's then really a question about who pays the most gas for these ones. And that's actually something we would like to prevent. Then another cool markets are definitely these X times Y equals K markets. That's how Vitalik calls them. And probably most of you know them just as Uniswap markets. So over there, like the fundamental thing is the invariant function. So if you want to trade tokens A versus token B, then you have that the tokens A times the tokens B multiplied should be equal to some invariant. And this basically gives you this curve over here. And now the trading is super easy. If you're at some point of the curve and then want to do a trade, then you simply look at how much tokens are actually sent. Okay, it's this much, and then you can see what the payout is. It's basically just this easy step function. So super easy market. I really like it because over here anybody can easily provide liquidity, and it's very decentralized. And this is definitely a market mechanism used by Uniswap, but also Kyber is using it with the reserve. They are calling it automatic reserve prices. But Kyber's biggest reserve is another one, and they call it the Fed price reserve. Over here there are three main ingredients. So what they're posting on-chain is once a price, second a target token ratio, T, and then they're measuring how much funds they actually have compared to this target token ratio. And with these numbers, then they actually compute for their customers the prices by basically just taking the price, multiplying it with some factor that depends on the sell volume that is coming in. So of course, if there are more sell volume, then they give you a little bit worse price. And they also multiply it with some function that depends on the actual delta T, basically how much of the trade will influence the target token ratio. But yeah, in general, in Kyber, I really like the approach that they have these different reserves, and we see that also now in the whole ecosystem, that people try to connect all the different liquidity reserves, and I think that's a very powerful feature that will definitely benefit everyone in the ecosystem. The advantage of these kinds of market is definitely that we have this automatic order book adjustment. So at Uniswap, basically, we have just this change of the point in the curve, and then once basically the point changed, we automatically are presenting different depth in the markets. That's super powerful. With Kyber's one, it was basically this delta T, how it influences the prices. And with that, it's very economic to kind of maintain these prices on the blockchain. Then, of course, they have also the atomic arbitrage, and that everyone can provide easy liquidity. But the disadvantage of these kinds of order books is definitely that they are less expressive than the usual order book. I don't want to go into this one too much. But now let's look at another one, which I'm personally very excited about. It's called the batch auctions. So imagine we again want to trade token A against token B, and then we are collecting these orders over a longer time period. So it's really not immediate trading. And then once we have collected them, we can create an order book. And the unique thing about this order book is basically that the order book is now overlapping, because usually overlapped orders are immediately settled, but over here they're not. Why not? Because later on we want to calculate then the optimal price. That's basically the price that maximizes the trading volume. That's exactly where the order books are basically overlap. And then we can settle all the orders with this optimal price. No matter how high basically limit price was over here, you're still getting settled with that. And well, there is some evidence that these kind of auctions definitely are a very fair price finding if you look at it from a theoretical point of view. They have also some advantage for that arbitrage cannot so easily be used by others. And yes, another thing is these ring features, ring trade features. So imagine we have again over here, we want to sell a token A for a token B, and we also unfortunately don't have the reverse order over here, the dashed line. So usually if you have just one order that goes just in one direction, you cannot trade the other way around. But if it also happens that there is a third token C, and that you can actually sell a token B for C and also sell a token C for A, then what you can do is actually settle the whole ring. And the cool thing about it is that this can be very easily be done with these batch auctions. Basically, you can find there also all the rings, but also it can be done with continuous order books. For example, the loopring protocol is trying to integrate them into their exchange. So let's look at the advantage of this batch trading and ring trades. So definitely these ring trades can provide more liquidity. The cool thing is about that we do not really have front-running possibilities, neither by an operator, neither by these gas auctions. But of course the disadvantage is that the price finding is a little bit slower, and also arbitrage in general is riskier because you don't know when you're posting your order whether you really will get the price or not. Right, so this was now already a lot of information, and I tried to summarize it over here in this feature matrix. So on the left-hand side you have all the features, and on the top you have all the different exchanges that we basically talked through. Until over here, basically we have all the permissionlesses, and then the permissioned, I have not yet talked too much about them. But let's go through these features. So the first ones are basically instant finality and atomic trades. And what we have seen is that most of the times you can either have the one or the other. All the permission exchanges usually have this instant finality because the operator ensures it. But then they don't have these atomic trades because basically the transactions are settled by the operator and not on the blockchain. The batch auctions are standard without because they don't have any of these first two features. But then if we are looking at the front-running issues, so basically the gas front-running and the operator front-running, then we see for the permission exchanges, definitely they don't have the issue with the gas auctions because the operator, again, plays the role with the matching. But of course, always there's a possibility that the operator could front-run. He's, I would say, not really incentive to do it, but it's also all the time very hard to prove if he does it. And for the permissionless exchanges, of course, there's no operator front-running because there is no operator. But for the gas auctions, it is really a small issue with some of the protocols. So for the batch auctions, we don't think that's a protocol just because you have the slower trading mechanism. And then for Kyber, Uniswap, and these on-chain order book exchanges, they have all found some way to mitigate it. For example, with special fees, and you basically define the maximal slippage that you're allowed to get when you're posting the order. But I think it's not yet a really perfect way to tackle it. That's why I put in here these small squares. And then for ring trades, definitely it fits very well into the concept of batch auctions, and Loopring is also deploying it. And then in the last column, what we put in is roll-up compatibility. So basically, how easily can you scale them with some zero-knowledge technologies? And we were looking into all the different papers that are currently out there. So definitely for batch auctions, the Diffusion Exchange described that. For IDEX and 0x, we know that, for example, the StarkDex is trying to do something like that. And Loopring and Text, they're also describing these solutions. Yes?
What about settlement risk? Have you considered actually, this problem that you sometimes have an instant finality, but then the settlement risk, and you can't be guaranteed? I mean, what is the use of the instant finality if my trade may not settle?
Exactly. I think in general, like the likelihood that if the operator says, hey, you actually get this price is then actually very high. But of course, definitely there's this risk. And I'm definitely not denying it. Like there is this risk, but I think like for the usual traders, like to the ones we have talked to, like they say that this definitely is a risk, but not something they're really concerned about.
Yeah, I guess all I'm saying is that, there's a trade-off, obviously, right? But maybe there's some advantage for certain use cases that instead of instant finality, you get the settlement risk-free trade, and your trade is actually guaranteed, right, to settle, in fact, in the same transaction. So
exactly.
It may not be instant because you have to wait for confirmation. Once it's confirmed, it's already settled.
Exactly.
Yeah,
and this is very powerful if you combine it with the whole atomic thing, so that you can then also kick off other actions with the same transaction. Exactly. Right, so this was basically now the rough overview of the technologies that are out there, and now I want to give you a quick heads up like what we are planning to do. So as you probably have felt it already, I'm super excited about these batch auctions just because we think that they have the check marks at the right spot. So definitely for some applications it will have a huge benefit, and we think the application that fits best into there is the conversion of stablecoins. So we all see basically these days there are lots of stablecoins being onboarded to Ethereum, to other chains, but then actually I think there is not yet a very efficient mechanism to exchange them. And what we want to do, we really want to apply these batch auctions, but we want to apply them in a very specific way. So please bear with me. It's now getting a bit more complicated, but we will make that. So what we will do, quite similar to the batch auction, is that we will collect these orders between different tokens. It's over here simulated between these 3 different tokens. So what we will get, basically, if we're collecting these orders over time, we are getting these overlapped order books between each of these tokens. But now we do want to really also take care of all the possible ring trades that could happen. So what do we gonna do? We are now looking for a uniform clearing price. And this uniform clearing price is the price that maximizes the trading volume. So exactly as in a 2-dimensional case, we are again looking for a specific price in the auctions that maximizes something. And over here we want to maximize the trading volume, which also, of course, at prices which respect the following constraints. So of course all the limit order should be respected. We should have price coherence. So basically if you go this price or the reverse, they should basically, if you multiply them, should be 1. It should be arbitrage free. So if you go this price, it should be the same as this one. And there we should have a preserved value. That means the amount of tokens sold over here equals the amount of tokens bought, and the same true for the other tokens. And then once we have calculated these specific prices, then we can do the actual settlement. And now what does actually mean? Like, how can we visualize that a little bit more? Again, imagine we have the 3 tokens with these overlapping order books. What we are actually doing is we are kind of mapping these order books into a more multi-dimensional space, where each of these points represents a set of prices. These prices must be arbitrage free. And then basically what we are checking for each of these prices, how many orders can we actually settle? Then we are calculating the trading volume, and then we are interested in the ones that have the biggest trading volume. And why do we do that? Because that actually means that all the ring trades are executed at the best possible price. We think that this kind of trading mechanism is really the best one if you're in a system which does not have a dominant token. For example, like if you're trading equities, definitely it's USD. If you're trading cryptocurrency, it's ETH. But in the stablecoin system, there is not really a dominant one. And we really hope also that there is not a dominant, that there is not a reliance on one single one. So really think that in this kind of system, you need these kind of ring trades to enable the best liquidity. And we also think these batch auctions are a really cool mechanism to really bundle the liquidity of the sellers and buyers over time so that they can be matched directly. And we have also a really cool mechanism that is kind of like Uniswap, that you can easily provide your liquidity to these exchanges for these stablecoins and actually then also earn some revenue. So that's roughly what we are trying to build. If you're interested into this, we have these Gecko ecosystem funds. We will push some tasks also around this diffusion POC out there. Follow it if you're interested. And yeah, for that, I would like to thank you for your attention. And of course, also always thank the perfect team working on that. Cool. Any questions?
Thanks so much for a great presentation. I'm sort of curious, well, I've got two questions really. How do you
what's the best way to track volume of touch checks today? Because it's sort of missing from most of the analytical tools, and I'm sort of curious what would be the preferred way. And the question number 2, can you say a little bit more about the rollups, because it was very interesting, but you sort of skimmed over this subject almost entirely.
Okay. So the Dutch X, I have not presented it over here, but it's basically an exchange that we also developed in Gnosis, and it was kind of working with the mechanism of the Dutch auction. We think it's a very good market mechanism for protocols that need to do some liquidation, because then auctions are really a good market mechanism. We were building this exchange, and now it does not really have too much traction, because there are also currently not too many protocols that actually need to do these liquidations. So we definitely keep that out, definitely keep it open, and we're interested in anyone who wants to build on it, but these days there's really not too much traction for just usual trading. And the second question was about this one. So there is this principle of rollup, and rollup is kind of the keyword for presenting a new scalability technology. And the scalability technology basically uses zero-knowledge proofs, and what it does is basically it lifts all the computation that we usually do on the Ethereum chain basically off into some proving mechanism. That means basically that the computation is no longer done on chain, but all what happens is that off chain we are calculating with lots of resources a quick proof, and then on chain we're only verifying this proof. And yeah, actually that's kind of a whole own talk, definitely. But we over here looked into how easily this technology can be used with these different exchanges. And we were definitely aware about IDEX, Loopring, and Text, that they really put out papers where they described how exactly they're going to do it. I think 0x, for example, does it with StarkDex, super exciting project. Loopring does it with Snarks, super interesting, and Text also does it with Snarks. Yes, and for the diffusion, for the batch auctions, we from Gnosis actually described a way how we can do it, and this paper will also be shown in a journal in the next weeks. Yeah. But do you have a specific question in that regard?
I was just sort of curious, in what context do you actually use this word rollup as such? Because what 0x and Stark was doing is very, very different than what Loopring is doing, for example, like on the technological, from the tech perspective, right? And the only common thing is that indeed, they're trying to put some computation off chain, and they're using some sort of a zero knowledge technique to actually do so, right? But,
yes.
but
I think the whole concept is always the same. It's always this.
But the word rollup, I thought that you meant, that by using the word rollup, you sort of assume that the data is actually kept on chain, right? As opposed to other techniques where you've got the data availability, issue to be solved, right? Like with Starkware, for example, and the StarkDex, that's one of the issues that, it's not as easy to be solved, right? So where and how to keep data off chain, and how to make sure that this data is actually available, because what's the use of the proof if you don't have the data that was used to compute the proof?
Yeah, that's just an issue that then the chains can hold, yeah. Definitely, I think different protocols are then using different trade-offs, and to my knowledge, StarkDex has not yet decided whether they want to really have everything on-chain or have this, how do they call it, custody of data
I think,
availability.
the idea is to have some sort of a, trusted consortium, whoever, party that will actually keep the data for you. But I guess it depends on a specific solution, because they provide the proving technology, and different DEXs can actually use different architectures. So I guess it's up to the specific DEX how they're gonna approach this problem, right?
Exactly.
Thank you. Now I just wanted to ask just about what the relationship is between the DEX and the prediction markets platform. Are they intended to be kept separate, or ultimately are they intended to be sort of bundled?
Of course, in the future, we would like to see them bundled. Like these days, we are really looking into these trading mechanisms as something we do a little bit more experimental at Gnosis. We first want to kind of verify that these trading mechanisms really work as we think in the blockchain environment, because of that it's also always something different. And probably like the first prediction markets, we will just go with standard, usual vanilla markets, we call them like that. And then, but if one of these models definitely proves to be a better one, then we will definitely take it. Great, then thank you all for the attention.